Good day everyone. Our project is titled Arduino based safe direction control of DC motors using interlock logic. My name is Arvin. So mobile robots are widely used in modern applications such as industrial automation and warehouse logistics. These systems rely heavily on DC motors to control movement. However, a common issue in basic robotic systems is that the motor direction can change instantly from forward to reverse. This sudden change can cause mechanical stress on the gears and electrical stress on the motor driver. Over time, this can lead to reduced performance, system instability, and even permanent damage to the components. Therefore, there is a need for a safety control mechanism that can prevent sudden direction switching and ensure smoother and safer operation. To solve this problem, our project introduces a robotic platform with a built-in interlock system. This system ensures that when conflicting commands are detected, the motors are stopped immediately instead of switching direction abruptly. The main objectives of these projects are as follows. First, to design and develop a mobile robotic platform using an Arduino Uno as the main controller. Second, to implement a safety interlock system that prevents sudden switching between forward and reverse motor direction. Third, to integrate a data logging system using an SD card module to record motor operation and safety events. Finally, to evaluate the performance and reliability of the system in ensuring safe and stable motor control. Thank you.
Now I will explain the hardware used in this mini project. First, the main controller of the system is the Arduino Uno. This acts as the brain of the project where all the logic is processed and executed. Next, for motor control, we use the L298N motor driver module. This component is important because it allows the Arduino to control the direction and speed of the DC motor safely. For the structure, we are using two-wheel drive robot chassis kit. It includes the wheel, DC motor, and a caster wheel, which help the robot move smoothly and maintain balance. In terms of input, we use two push buttons. This button allows the user to control the movement of the robot, specifically for forward and reverse direction. Lastly, we included a micro SD card module for storage purposes. This can be used to store data such as movement logs or system information if needed. Overall, these components work together to create a simple but functional robotic system. Next, I will explain the methodology and logic behind our project. We followed a structured development approach. This means we started from research and circuit design, then move on onto hardware construction and finally testing. This step-by-step process helps ensure everything works correctly. One important feature in our system is the interlock condition. With both buttons pressed at the same time, the system will immediately stop the motors, and this is a safety feature to prevent conflicting commands. We also use incremental testing. Each part of the code was tested separately before combining everything. This helps reduce errors and make troubleshooting much easier. Finally, we perform verification by checking all hardware connections step by step. This ensures there are no wiring mistakes that could affect the system performance. So overall, our methodology focuses on safety, accuracy, and systematic development. That's it. Thank you.
Now I want to present about result. To see if our interlock system works, we run several tests. Here is what we found. The robot moves forward or backward perfectly when one button is pressed. If you try to press both buttons at once, the interlock kicks in and stops the motors immediately. The system is fast, reliable, and does exactly what the code tells it to do. Next, I want to present about discussion. It wasn't always smooth sailing. We had to fix a few things during the build. At first, the switching was a bit messy, so we refined the code to ensure the robot stops completely before changing direction to prevent jerking. We deal with loose wires and power drops by tightening our connection and making sure the battery supply was stable. This fix helped us reach our goal of reducing stress on the gears and the motor driver. Finally, let's look at the big picture. It cost us 36 ringgit to build, and we believe it could sell for 50 to 60 ringgit. This is a great tool for students or beginners learning robotics and safety logic. We successfully built a robot that isn't just mobile, but also smart enough to protect its own hardware. That's all. Thank you.
This is the demonstration video for the mini project regarding interlock logic on DC motor. So now this is the connection for SD card module and the breadboard connection. This is the Arduino Uno connection, and this is the chassis, the motor and the battery pack connection. And now we will be testing this for about 3 times to obtain a readable graph in order to get a real-time data for plotting the graph. So the command is when the forward button is pressed, the chassis should move forward. Same goes to reverse. So when the reverse is pressed, the chassis should reverse. But interlock occurs when both buttons are pressed. As we can see in the video now, when both buttons are pressed, the chassis doesn't move. This shows that the interlock occurs and presence to ensure that there is no mechanical or electrical stress happens on the motor, and so does the chassis. And it will make the chassis last even more longer than we expected, not like a normal RC car that we use. So this has been tested more than few times to ensure plottable graph.